Hello guys and welcome back. It's me, Learning Nugget, and today we will talk about the topic of propositional logic. This is the first introductory video in the series Learning Propositional Logic, and let's get right to it. First of all, there's a tip I want to give you, and this is simply watch this at like 1.5 to 2x speed, okay? Because otherwise it would get very cumbersome, and you should also I also apologize for my really bad handwriting. It's yeah, not so beautiful obviously, but yeah, that's it. Okay, let's talk about propositional logic. Let's skip this part for now, okay, and let's just talk about what logic is. Logic is the question of logic, one could say, is what makes inference correct. Okay, this is one way of thinking about logic, and by that you can already see that it is quite normative, because the term correct is obviously a normative notion, right? You since it's normative, and since the question already suggests it, this is also logic is also formal. Okay, meaning it's not empirical, so it's not empirical or in somehow descriptive. Yeah, so when sometimes people use the word logic in a very bad way, a very incorrect way, because they say, yeah, logic is about the way we reason. Yeah, no, it's not about the way we reason, it's how you should reason. It's how you it is about how you can make correct inferences. So it's formal and it's normative. This is very important. Many people get this wrong. Okay, so let's think about what the inference is in the first place. Yep. Inference. This may be a weird word because it's you don't hear it that often, obviously, but if we think about this word in a sentence, it gets way clearer, actually. To infer something is to conclude something, okay? And to conclude something simply means, okay, I have a set of propositions. Can think about them as just sentences for now. I have another video where I talk about propositions, so I'll link that video below in the comment section. From which S, some reasoning being concludes, I call the set of propositions just P, concludes that one or many different propositions, call them P prime, are true. Okay, let's think about this. Let's give you a very easy to understand example. And this is of course a very standard example. It's a bit boring, but I think it gets the point across pretty well. let's say we know that all mammals are warm-blooded. I don't know if this is true actually, but just stick with me. It's actually a good example if it's not true. A dog is a mammal. Thus, we can also symbolize this thus by just 3 dots. Or we could say all dogs are mammals. Yeah. All dogs are warm-blooded. Okay. This is obviously a correct inference. But you can think about this as a set of propositions. Propositions. I call it P again, and I define it to be just here. Let's call this P1. This is barely a 1. Let's call this a P2. And we define this set of propositions P1 and P2. Okay, this is all that is to it. Let's call this Z for, you might have guessed it, a conclusion, but obviously this is also just a regular proposition. So we can write Z, the set C. We can just define it as having a single element, and this is proposition Z. Okay, so this example gave a little bit of life, I hope, to this abstract formulation above. So we have a set of propositions. So let's think about this. Let's think about a person who actually believes P1 and P2. So we have a set of propositions, namely these two, from which S, a reasoner, concludes that one or many different propositions are true. Okay? But what I wrote here in the beginning is actually not that good of a definition. Set of propositions P, and this is very important, taken to be true. Very important. Okay? When we are concerned with questions of logic, we always suppose truths. Okay? When we want to know whether this is an instance of a valid reasoning process, or if this is an instance of a if this is a logically valid argument, what a logical validity means I will talk about later. But we are not concerned with the empirical questions whether all mammals are actually warm-blooded. This is totally besides the point. This would be an empirical inquiry. And logic is, as I already told you, it's a priori, it's formal, it's normative. Okay, somehow many people don't understand this. The question whether this is true is completely irrelevant. We suppose P1 to be true. We suppose to be true. P2 to be true. Okay. And we say, okay, let's take P1 and P2 for granted. Is it actually possible that even though P1 and P2 is true, Z is false, or is this not possible? Okay? If the truth of these two propositions guarantees the truth of this third proposition, then we talk about a valid argument. Then these sentences are logically structured in a way that guarantees that if these two things are true, this other thing, which we say logically false from it, is also true. Okay? Of course, in this case, we can easily understand why this is the case. We can think of a Venn diagram. Okay, a Venn diagram is just a set theoretic notion. Let's say this is an omega, something like that. We say all mammals are warm-blooded So let's say this is the set of all warm-blooded things, call this VB, and inside of that set there are mammals, okay, the cursor is a little bit too thick, so I can't write it here. But think of this circle as representing all the things that are warm-blooded, and think about this circle as being comprising as being comprised of all mammals. And then we say all dogs are mammals, so we write a little circle in the middle of it, okay? And we can obviously see that this set of all dogs is contained in the set of all mammals, which is contained in the set of all warm-blooded things. So thus, it just logically, set theoretically even, one could say, follows that all dogs are warm-blooded. Yeah? So I think by giving this example, I could clearly show you the difference between logic and empirical investigations. I showed you the formal character of logic. I showed you that it's also normative, because we are talking about correct reasoning, and this is an instance, we could call this an instance of a correct logical inference. Okay, you can see the notion of correct is obviously a normative notion. So yeah, and this was the main aim of this first little video, to actually give you an intuitive, more or less intuitive understanding of what logic is all about, and the way logic differs from descriptive empirical ways of inquiry, let's say. Okay, let's make this a little bit, let's structure our thoughts again and make this a little bit clearer. Okay. Let's think about what I just said. We have a set, I don't know why I did the little dot there, set of propositions. I call the set simply P, and this is comprised of P1 to P2 ... Pn propositions, okay? And then we have another set of propositions. I'll call this Z of simply C1 to C2 to C3 to C to Cn, yada yada. Okay, I call P is the, call it premise set. Z is the conclusion set. Okay, and just to make things a little bit more convenient, let's just think about the conclusion as being comprised of just one proposition. Okay, of course, if you have lots of sentences, many different things follow, but this is not how I should introduce the topic. So just think about Z is what we could call the conclusion, the proposition inferred from the premise set, from P. Okay, singular, that's important. Okay, so we have a set of premises and we have one single conclusion. And just to make things even simpler, I will just talk about the special case where the P only consists of two propositions. Okay, just to make things easier. Now let's think about what an argument is in a formal sense. When we argue about stuff, when we try to convince each other that something is true, we always have to start somewhere, and these are the things which are just taken to be true, because otherwise infinite regress would loom. And these propositions that we take to be true and that we communicate to the other, these we could call the premise or the premises of the argument. And we try to show the discursive partner that if he accepts these two premises, we try to show, and if we infer in a logical correct way, then this is actually true. What we are trying to show is that if you accept these two premises, you also have to accept the conclusion, because the conclusion logically follows from these premises. Okay, so this is what an argument is, and let's just write it down right here. Let's give you an example first. I call this premise 1. I call this premise 2. All, it's also a very standard example, I'm sorry. All humans are mortal. Socrates is a human. Thus, this again. Socrates is mortal. Okay, and this is a correct inference, because if these two premises are taken to be true, they logically imply this conclusion Z, that Socrates is mortal. Logical implication. Implication is a very important concept in logic, so let's try to have this concept in the back of your mind. And once again, we can show that this is a valid form of reasoning simply by showing you what we call a Venn diagram. But this is not part of logic, this is part of set theory. And you can think about the combination of logic and set theory as the basics, the foundations of mathematics. And let's say this is the thing, or all mortal things. We can see that inside of this set of all mortal things there are humans, because they clearly are. And inside of this there's just old little Socrates. So we can just see by looking at this picture that Socrates is mortal. Okay. And if you wonder why the set of the humans right here and the set of the mortal things is not coextensive, meaning it's not just one single circle, this is simply because this is not guaranteed, right? Because all humans are mortal does obviously not imply that all mortal things are humans. So this is very obvious, but people often commit logical fallacies, which are in this category of stupid. So we should beware. Okay. So let's think about this again. We call, let's say, an argument. This is a very informal way of putting this. This can be, what I'm giving you is a very hands-on introduction to propositional logic. You can become way more abstract than I'll be introducing this topic right here, but this is not the point. This YouTube lecture series is just to give you an intuitive understanding, so you can make research on your own if you'd like. And if you conclude this series, you know more about logic than 99% of people I've met, so there's something to be proud of, I guess. Okay, we call an argument logically valid there's the word I talked about earlier, if and only if, so this is a definition, if the truth of Z, what we call the conclusion, is guaranteed by the truth of P, the argument's premises. I really don't know how to pronounce premises, but that's all right, okay? Okay, logically valid, the truth of the conclusion is guaranteed by the truth of the premises, okay? So if we look at P and if we look at Z, these are just, think about them as being the two propositions above, okay? P is just a placeholder for all humans are mortal and Socrates is a human, okay? And Z is just a placeholder for Socrates is mortal. We are just generalizing now, okay? And what we say is, if P is true, then it cannot be the case. Think about this as representing it can not be the case. It is, we could also write this, it is logically impossible that Z is false and the truth of P implies, we could say, guarantees, this is another way of talking about it, the truth of C. Okay, these are equivalent ways of putting one in the same thing. So once again, just to drill it down, we call an argument logically valid if the truth of the conclusion is guaranteed by the truth of the premises. Okay, what I mean by this is a correct way of reasoning. This is a logically valid argument from the premise that the conclusion logically follows, simply because if P1 and P2 are taken to be true, then Z must be true because it is a conclusion. So the truth of the premises guarantees the truth of the conclusion. Yeah, and this is why logic is such a powerful tool, of course, in debating in discursive settings, because if the other discursive party agrees on certain propositions, then you can take them to be true, you can put them in your bag, so to say, and then you can just look at what follows from them. And if you reason correctly about it, the other discursive partner has to accept them simply because he said that these premises were true. Of course, he can backpedal and say, okay, wait a minute, maybe the premises aren't true, but then he's in a bad discursive position, right? So yeah, this is a very, very important definition, so I'll give it a big exclamation mark. You should maybe write it down, memorize it, but mainly, of course, understand it. Okay. Okay, we're now at 23 minutes. I'm debating whether I should go on or just leave it at that. Yeah, I think I leave it at that because it's much input, I know. And yeah, see you in the next video where we start to actually look at some examples of propositional logic and formulas in propositional logics. Okay, see you then. Bye bye.